Hey guys, let's understand another very important problem, trapping rainwater. This is mostly asked in Fang-based interviews. Most of the time it asks in Google, Amazon, likewise. So this is a hard problem of Leetcode and it is very good problem of two pointers. This can also be solved using brute force approach and dynamic programming, but the most optimistic uh, like result which we'll get is the time complexity and the space complexity will be minimal for two pointer approach. So let's see how we are going to solve it using two pointer approach. So yeah, before that we will understand the problem. So in problem, you will be given n non-negative integer representing an elevation map, the map which you can see over here, right? There will be an elevation map. So, and the width of each bar. So here you will be given in the elevation map, you will be given the heights of a bar and the width of the bar will be 1 unit. So that is what they have seen. So as you can see here, heights is given in this array. First is 0, 1, 0, 2. So it's like 0, again 1. This is again 0, 2, likewise the height will be, and you have to calculate how much water you can trap in middle of this. So this is how you are going to solve this problem. So as you can see, like you can keep on a very high level observation only you can see like you can keep one left pointer here, right pointer here, and you can move this left toward right, and you can do some calculation in between to calculate the trapped water. So this is a very straightforward for the two pointer problem. So let's see how we are going to solve it using the two pointer. We'll understand the algorithm for this. Okay. So understanding the problem already you understood. So coming to Notepad. So again, I'll just give you an overview. The trap water problem involves like finding the amount of water that can be trapped between two bars. Suppose if you have given two bars like this, right? So this is two bars. So in between how much water you can trap here. This is the amount which you have to find. Okay. So as you can see, I already told you, right? We can have some left here and right at here. Suppose if we have bar like this, then you can have right over here and you can move this forward and you can do likewise the way you can do it. Now, coming to the algorithm, how we are going to write the algorithm for this. So the very first thing what we will do, we'll do certain initialization. So let's keep like, we'll do initialization. Initialization, what all the initialization we will do? We will have the left and we will have the right. Okay. Why we will have this left and right is because we will start by initializing two pointer, that is left and right, pointing to the first and the last of the elevation bar. So we will keep this left at 0 and this right at n minus 1, means n being the length of the heights, what length of the heights which is given in the array. Okay, so this is our two initialization we will do. And additionally, we will do few more initialization, that is max left, max right, max left and max right, and water trapped. So these, why we will do these all initialization? Because this will be containing the max height in counter to the left. Okay, to left so far. Max height in counter to right. And this will give you the water trapped. Like we can store the total trapped water. So store total trapped water. So this is our few initialization. Now we will move forward to understand. We will move the pointers toward each other. This left and right pointer which we have, right? So these pointer we will move toward each other. How we will move? We will run in a while loop. We'll say as long as left we have is less than right. Okay. Do one check, that is if height of left is less than height of right. Okay. If this is the case, if this is less, then we will check one more thing, that if height of left This is to update the max left which we have. If height of left is greater than or equal to max left, because we need this. Why? Because max left need to be updated always. So if we have, suppose if we have water, like if we have this scenario, right? Something like this, we cannot store water on top, right? So that is what always max left need to be known. So if this is greater, then we will do nothing. We will just update the max left with the height of left, whatever the height which we have, height of left will update. Okay, this will be getting updated this way. And if this is not true, then in else part, trapped water. How we are going to calculate the trap water? Suppose if you want to calculate the trap water at this point, then you have to subtract from this to this. So we will just subtract the max length minus height of left, whatever which we have. Okay, so sorry, max left minus height of left. This is how we can calculate the trapped water. Okay, and we will do this, and we will store this inside trapped water. It will be stored inside the trapped water. The same convention we will follow for right. We'll check if height of right is less than height of left. If this is true, then again we will check the height of right. If it is greater than equal to maximum right, then we will just update the max right to the height of right which we have seen here. And then we will, again, if this is not true, then we will calculate the trapped water with the max left minus height of, sorry, max right minus height of right which we have. So this way we can calculate the water. Okay, so let's understand this using debugger. It will give you more sense. So explaining on very high level, this is base case which we are checking. There should be some height error should be there. It cannot be null, or length cannot be 0, because there is no sense if we are doing any further calculation if this condition satisfies. So we will be just returning 0 in this case. After that, we will initialize left, right. Left will be 0, right will be the length, and the max left will be 0, max right will be 0, water trapped will be 0. So this is what we have seen in the note also. So this was our initialization. Then we'll be checking while left is not crossing the right. As long as this is not satisfying, we will do this calculation. We will do what calculation will do. Height of left we will see if the height of left, whatever the height which we have at left, if that is less than height of right, then we will do this check. We'll check height of left is greater than max left. So max left is initially 0. If it is greater, right, so we will update the maximum left over here. So this is necessary to keep always track of the maximum left. If this is not satisfying, then there is a possibility that we can trap the water. So how we can trap the water? We will be subtracting like height of left from the maximum left we have seen so far. So this is how we have seen there. So we'll see using the debugger. Let's keep a debugger point at this point, and we will run the very first test case. This is the test case we have seen from the Leetcode. The same expected is 6. That should be coming over here. So I'm running in a debugger mode. This will come over here. We got the height. We got the same height which we have passed there. So now we will initialize left 0, right 0. Sorry, we'll initialize left 0, right 11. And then max left 0, right 0, max right 0, and water trapped initially 0. We'll get inside this. So this is true, right? Because left is 0, right is 11. So this will satisfy. So we'll come inside this. Height at left, what we have 0. So 0 is less than height of right. Height of right means 11. 11, what we have 1. So 0 is less than 1. So that this will satisfy. It will come inside. It will check again, one more check. Height of left is greater than max left. So max left is what? Max left is 0 now, and height of left is what? That is also 0. So this will satisfy, and it will come inside this, and it will update the max length through 0. So Max left will be 0 now. So height of left is 0. So this will be getting updated with 0. So you can see max left became 0. Again, in the next iteration, we'll do left plus plus and left will become 1. So at 1, we have 1. At 11, we have 1. How? This 11, we have 1. So this satisfy, it will go inside. And after that, this will also satisfy. After that, the max left will be getting updated with height of left what we have. So what we have 1, so max left will get updated with 1 over here. We'll come here, we'll do left plus plus, left will become 2 this time. 2 means we'll get 0. Okay, so again it will be height of left, that is 0. 0 is less than height of right. So this will be coming inside this, and it will satisfy 0 equal to 0. So this will come inside this, and then height of left equal to height of left what we have at left. Left we have 2, so 0 is greater than equal to max left. So max left what we got 1. So this will not satisfy, so we'll calculate the trapped water. So max left what we have max left as 1, and this is height at left is 0 now. So 0 minus 0, 1 minus 0 is 1. We'll get the water trapped at 1 at this point. Okay, so again we will go here, again we will come and we'll get left 3 this point. 3 means this 2. Again it will compare. What is at 11? We have right is 11. 11 means 1. 1 will get compared with 2, which is greater. 2 is greater. So this time it will go to right part. And again, we will do the same thing, whatever we are doing over there. So it will check for the if height of right is max right. So in this scenario, height of right, what we have 1 and max right being 0. So this is greater. So this will satisfy. It will come here and we will update the max right. Max right will be getting updated with 1 over here. And then right minus minus, it will become 10. Okay. Now again, we will go here and again, we will do the same check. What we got left now, left we got 3. 3 is 2. Here, right, at third position we have 2, and we at 10th position, we have 2. So this will satisfy. 2 is greater than equal to 2. So it's like got satisfied. Now max left will get updated with the 2 value. Now again in the next run, the left will become left plus plus, that is 4, and at 4th position what we have 1. So 1 will be 1 is less than equal to whatever the height of right which we have. At height of right what we have 1, that will satisfy. 10, that will then again it will satisfy, and it will be coming inside this max of left. And this will be again calculating the trap water. So trap water will be getting calculated max left what we have. Max left we have seen 2 minus height of left. Height of left, what is height of left? Left being 4. So at 4 what we have 0, 1, 2, 3, 4, 1. So 2 minus. So again 1 amount of trap water will be coming here. So this will become 2. The same iteration will go till last, and at last we will get the total amount of water trapped. Okay, so you will see the trapped water, whatever we had expected that, and this returned. This expected is 6, and the response which we got out of this, if I will evaluate this expression, the response which we got, that is also 6. So this test case satisfied. So this is how. So so it is as simple as that. So let's take this code and we will paste it over here and we will just run it. You'll see it got accepted. So this is how you can do it. Thank you everyone. See you in the next video.